I think I'm fine. Thank you. Oh, no, I don't see you anymore. I'm not sure that's perfect, but anyway. Welcome. Just quickly testing. Yeah, we're good. All right. Welcome to the Spring Framework talk. This is actually a core Spring Framework talk, so I'm not going to talk about Spring Boot. Well, I might mention it once or twice, but the talk itself is about the heart of the Spring component model. This is a source code talk, so we're going to talk about, we're going to see a lot of source code, and we're going to talk about source code. There are no bullet points in the entire talk. It's not a live demo, though. We're going to review source code examples, basically slide by slide, from the very core of the component model, the essence of the annotation-based component model in Spring, up to, well, a selection of endpoint examples. So towards the end of the talk, we're going to see what the endpoint model looks like. HTTP endpoints, Spring MVC endpoints, messaging endpoints, stylistically, right? I'm not going to do a full deep dive on every one of those areas. I am going to show you some selected special features in Spring, some favorite features of mine, some of the features that I find underappreciated, not as well known as they should be. So we are going to dive a little bit deeper in some areas, but overall I'm trying to whet your appetite. This talk is about showing you many facets of the Spring component model. I hope that there's something in it for each and every one of you. Very briefly, on myself, my name is Juergen Hoeller. I'm the Spring Framework project lead, so I'm responsible for both the co-development in Spring, for managing the releases, and I've been doing this for a long time, almost 13 years now, so from Spring Framework 0.9 up until 4.2, and currently about to do the initial preparation steps for Spring Framework 4.3 already. Spring Framework 4.2, mentioned in the title here, refers to the state of the art, right? This is not a what's new in Spring 4.2. It's a review of the Spring component model at the 4.2 state of the art level. So there are some 4.2 features in there. I'm going to mention some of the features that they are very new, but otherwise, the point is, we are going to look at the Spring component model in its most modern incarnation. And it's not really that important when those features have been introduced. There are some older features, some newer features, some brand new features here. It's not important. It's a comprehensive, coherent, overall programming model that we're going to talk about. Okay, let's start. At the very core of the programming model is the idea, the notion of a Java class, a regular Java class, using standard Java language features with selective use of annotations. So this is just a typical Spring class, a Spring managed bean class. It's a regular Java class, implements an interface, uses constructors, uses public service methods, but it has a selection of annotations on it that really turn it into a Spring component class with the annotations expressing certain characteristics of that class. So this is basically a Java class, just called my book admin service. But it's not just any Java class. It's a Java class with a specific role. And the role comes in through the add service annotation on top. Add service, the annotation on top, formally makes it a service class. Not just through the name of the class, but through a formal metadata element that is the add service annotation. Add service is an example for a stereotype. The stereotyping model is actually a pretty old idea, right? Back in UML, Unified Modeling Language, there was already this notion of a stereotype in a UML diagram. It's the same kind of idea. The stereotype says what kind of class this is, gives an indication of the role of the class. We ship a couple of out-of-the-box stereotypes, such as add controller, add service, add repository, and the pretty generic add component stereotype. So this is just an example. It's add service in this particular case. At the constructor level, so just in the middle of the source code example, we have a constructor saying, in order to build this class, I need to build an instance from this class, I need a reference to an account repository. Account repository is just some other bean in the application's context. So what we're talking about here is dependency injection, getting a reference to some other managed component in the system. My book admin service needs an account repository. In other words, it wants to be auto-wired with an account repository bean. The add auto-wired annotation makes this constructor a dependency injection constructor. It's a hint towards the runtime framework that at runtime, the resolution algorithm is supposed to provide an account repository here and call the constructor with a valid reference to the account repository. This is not just about runtime behavior, it's also about readability. You can actually read those source code elements. This my book admin service constructor is auto-wired with an account repository. You can read this as an English language sentence. That's why the annotations are named the way they are. That's why auto-wired is descriptive and not an instruction. It's adding readability to your source code. When you look at this piece of source code, you can roughly understand what it is doing. There may be other constructors, but they are not auto-wired. The other constructors may be used for testing purposes, right? So it's kind of an indication of what the source code element is supposed to be there for, right? Why it is designed the way that we find it here. The transactional annotation for our update book method down here is the third typical kind of annotation found in the Spring Component model, allowing to tap us into a middleware service, into some kind of runtime service, typically. Right? So the way we tend to think about the transactional annotation as seasoned Spring developers is more like, there's going to be a transaction manager. It's going to start a transaction, then our method gets called. And at the very end, there's going to be a commit or a rollback. The framework is therefore going to intercept our method in order to do those start, commit, rollback calls. That's, again, the runtime side of this equation, right? The edge transaction annotation is also about readability again. We look at this method, and we can see that the update book method is transactional. Again, that's why it's named descriptively. It's not called add transaction attribute or add start transaction. It's called transactional in order to read nicely. It describes the annotation as having a specific characteristic that it is, by definition, a transactional method. So again, it's about readability in the source code and runtime behavior in the same metadata element. This is going to show in many further examples here. But let's dive a bit deeper. Annotations in Spring, and typically the stereotype annotation, is composable. So they are composable. My service in particular here is an example for a composable stereotype. We take an annotation of our own, we declare it within our codebase, in the application's codebase, just as a public add interface, just a regular Java type, really, just a standard Java type, in this case, a custom annotation that you define in your application codebase. It's meta-annotated with a couple of other annotations. So this my service that you declare in your codebase is meta-annotated, so has annotations of its own, using typically standard Spring annotations. So it says like, I'm a standard add service, but I want to change my default scope to session. I, by default, have a primary role. This is something in Spring that you can indicate that in case of a dependency injection conflict, you want to win. It's not really important what it does. It's just a further characteristic that you combine here. And it even has a default transactional rule. All public service methods, all calls to public service methods from outside of the instance are going to be transactionally managed. These characteristics in combination, that's what your my service annotation means, effectively. So every time you're saying at my service, like down there, for any class that you're annotating with at my service now, you really annotate it with the combination of characteristics above. Service, scope, primary, transactional, all in a nice shortcut. So from that perspective, this is a shortcutting model. You just say at my service and you really combine those rather extensive characteristics above. But it's also an opportunity to give it a proper name. So at this point, please do not call those annotations like my service. Give it a proper name. a name that has a meaning within your architecture, within your application architecture. Call it order service, account service, name it after a vertical or horizontal slice of your application. Indicate the role of this service type in this particular case within your architecture. And then you get the best of both worlds. A custom named annotation, a nicely named annotation that tells you something about the role of the class, and a couple of default characteristics that come with that annotation. So composability in Spring, composability of annotations is actually a pretty powerful feature, in particular for larger code bases, larger architectures, larger development teams, where for a specific project you set up a couple of those annotations out of the box, of your own, with the characteristics that you want by default, and then everybody in the development team is going to use the same set of annotations with the same predefined characteristics. Couple of further little specialties here. Composable annotations can even have attributes. And we actually have two further examples for composability to begin with. Almost any annotation in Spring's component model is composable. So wherever you're using a standard Spring annotation, you could also use a custom annotation that you declare yourself, meta-annotated with the standard Spring annotation. So the above, for example, is a custom scoping annotation. You could call it my session scope, but call it session scoped or just session, right? Forget about the my prefix. The my here just says it's a custom annotation for you to differentiate between standard and custom annotations here. So my session scoped is meta-annotated with add-scope session. It's kind of a shortcut for add-scope session. It hard-codes the session scope name, so every user of my session scope cannot really mistype the scope name anymore. But it also overrides an attribute. It exposes the proxy mode attribute. Proxy mode comes from the standard scope annotation. It's kind of mirrored in our custom annotation. You chose to do this here, right? You don't have to do this. You could just skip the attribute. But then nobody could change the proxy mode. No user of your annotation could change the proxy mode. By redeclaring the attribute, you explicitly allow the users of your annotation to change the proxy mode. And you could even choose a default proxy mode of your own, right? Here we say scoped proxy mode no, which is the default in add-scope itself. But you could switch it to scoped proxy mode target class by default. Nothing wrong with that. There's a lot of subtle design effectiveness in such custom annotations. The example below is a custom transaction annotation called myTransactional here. You could call it myTX or just TX if you want it to be really brief. Just two-letter names for annotations, why not, right? So this custom myTransactional annotation is meta-annotated with @transactional and the rollback rule, not that important really. So it's meta-annotated with the Spring @transactional annotation. You could use myTransactional all across your code base, just as a replacement for Spring's @transactional. The design element here comes in through the attributes again. Spring's standard @transactional annotation has many attributes. It has a timeout, it has a propagation behavior, isolation level, it has many things. Maybe you do not want your application developers, your team, your project, to change any of those, right? You don't want to expose the isolation level and the timeout. You want to have defaults for those. And you don't want anybody to change them. Through declaring your custom annotation, you can select the attributes that you want to expose. Everything else is not modifiable for a user of your annotation. So on this myTransactional annotation here, there's no propagation behavior, no timeout, no isolation level. There's just a read-only attribute. And that means for a start. That's the only thing that your developers can change, your team can change. But there's also a further subtlety here. This read-only declaration does not declare a default. There's no default clause, right? In standard Java language rules for annotations, you can declare a default for annotation attributes, but you don't have to. By not declaring a default here, you're forcing the users of your custom myTransactional annotation to explicitly say read-only equals true or read-only equals false. You're forcing them to set it because there's no default. And that's intentional here. It's a matter of guidance. You force the users of your annotation to reason about the read-only status, because they have to set it. They will have to think about it, right? Is this transaction scope here, my transaction scope here, read-only by nature or not? And they explicitly going to tell you through saying true or false. If there's just a default here, read-only false, it's easy to forget about it, right? And read-only can be an important runtime optimization hint. In particular, if you're using Hibernate, if you're using a MySQL cluster, the read-only status can be pretty important. And it's one way to enforce it. All right, just a quick variant of the previous example. That's the same two annotations, but as of Spring 4.2, if this looked a little bit magical before, because the redeclaring attributes thing is by name, right? Proxy mode, it's just the same name as in the standard AdScope annotation. Here it's a little more explicit. The attribute name is actually shortened to mode up there, and there's this alias for annotation up there that says, I am, this attribute is an alias for the proxy mode attribute in Spring's scope annotation. Very explicit. Of course, the runtime infrastructure understands this. Spring then knows that this annotation, the intention behind that attribute declaration, is to override that specific attribute, no other attribute. If there's another attribute of the same name, doesn't matter. We just override this one. So it's very explicit for the runtime, but it's also explicit for the source code readability side. If you look at this declaration, it's clearer what the original author of that annotation actually wanted to do. Because that was maybe not you, right? Somebody else authored that annotation, and that somebody else meant to override that specifically named attribute. And it allows you to change the name of the attribute, so it's also a feature, a specific feature that you otherwise couldn't achieve, because otherwise you have to use the same name that the original attribute that you're overriding was declared with. All right, so much for composability of annotations. Let's switch to a different topic. A quick summary of what configuration classes do, and a selection of variants of what you can do with configuration classes these days in Spring 4.2. So that's a typical example, somewhat rich example, for a configuration class in Spring state-of-the-art. A configuration class is a standard Spring managed component with a specific stereotype on top. Add configuration makes it a configuration class, just like repository, controller, service. We have a configuration stereotype here. Configuration classes have a purpose. They are basically a collection of admin methods. They are meant to have a selection of admin methods. So there's one example here, further ones probably in the same class. There can be any number of configuration classes with any number of admin methods. So it's one way for you to choose the granularity of your configuration arrangement. It's your choice how many configuration classes, how many admin methods. You could have all of them in the same class, or spreading them out over any number of configuration classes, whatever makes sense for your purposes. Configuration classes have admin methods. Admin methods are just regular Java methods with a specific role. They serve as a factory method. So in the end, the container is going to derive a bean definition from each such method, and it says like, okay, I know about this bean. This bean is named my bookadmin service after the method name. It has a type hint, which is the return type from the factory method, and it can have characteristics in addition, right? Like the AdScope session. It's just the same annotation that you would use at the top of a regular component to indicate its scope. And every time the container needs to create a fresh instance of this bean, it's going to call your factory method. There are a couple of specialties, like you can call other factory methods, and the container understands that that's a symbolic reference to some other bean. It's going to intercept it for lifecycle management. Let's rather forget about this for the moment. Design-wise, it's really a factory method arrangement. Keep in mind, it's a factory method, not a lookup method. The container is going to call it whenever it already decided to create a new instance. If an existing instance is going to be reused, the container already has its instance registry. So you're not going to see a method call for this method unless a new instance needs to be created. For a singleton bean, this method is only going to be called once on startup, or the first time the bean is initialized, depending on whether you declared it as lazy, for example. A quick look towards the top. Add configuration we already talked about, but there are two further elements up there. add_profile is an example for a condition. And conditions, that's what Spring Boot really explores to the maximum extent possible, right? Spring Boot is basically conditions on steroids. This is a pretty simple condition. add_profile standalone just says this configuration class and all of its bean definitions are only to be made active if the profile standalone is marked as active on startup. A simple way to include or exclude certain beans depending on a system property or some other kind of profile setting on startup. Add-enable transaction management, another example for something very important in Spring Boot. It's an add-enable annotation. A simple, convenient way to activate certain framework behavior across your application. Transaction management, the processing of transactional methods, is not on by default in Spring. Spring's container functionality is fundamentally opt-in. You instruct the framework to activate certain parts of its infrastructure. And certain elements of this infrastructure can be intentionally deactivated. You can deactivate caching. You can deactivate transaction management simply by not having the add-enable annotation in there. If you want it to be active, add the add-enable annotation that you need, add-enable transaction management. Add-enable transaction management needs a transaction manager in the system. There's one bean that you declare that chooses the transaction manager implementation. That's all you need to do. The framework does the rest for you. But it's fundamentally explicit. It's a kind of what you declare is what you get principle, not just magical auto detection of things all over the place. In the core Spring framework, things are pretty explicit. Spring Boot adds a well-defined layer of conditional configuration, but it's still very explicit in the end. It's easy to follow, easy to track what actually happens at runtime. All right. Configuration class variants. Configuration classes are regular Java classes. You can choose to use extension, inheritance. You can extend from some other configuration class. Let's say we have a my application config, extending this other one, my bookadmin config. If the base class, my bookadmin config, has admin methods, then this concrete class, the extended version, is going to inherit the admin methods from the base class. It could selectively override a couple of those methods if it chose to do so, but it doesn't have to. All right, so it's a standard Java language concept, inheritance, class inheritance, applied to configuration classes, allowing you to compose base classes that can be reused across different parts of your system. You could even design abstract base classes with a couple of admin methods and a couple of abstract methods that need to be filled in by your concrete class, allowing you to create configuration fragments that can be completed through subclassing. It's a very powerful design concept. Configuration classes are Java classes and can use inheritance. Configuration classes are Java classes and can not only use inheritance, they can also implement interfaces, just like any Java class can do. So what happens if my application config implements an interface, and as of Java 8, interfaces can have default methods, methods with a method body, and they can be annotated. So what if a configuration class implements an interface, and that interface has like admin methods with a body? Historically, we didn't actually process those, but as of the current Spring Framework generation, we do understand what you're telling us here. If you choose to use default methods, and you annotate them with @bean, we consider them a valid bean declaration method, even if it's in an interface. That's a pretty powerful design concept in its own right. Your configuration class may implement several interfaces. You can only inherit from one class. You can only extend one base class, but you can implement multiple interfaces. And if all of those interfaces have some admin methods, Java language rules apply, right? They are going to be merged into your class hierarchy. You can still override them in your concrete class. There's no state in the interfaces, so there's no state that can collide. But it's basically multiple inheritance for admin methods. So we don't, of course, force you to do any of this, right? You can just have regular configuration classes, no extends, no implements. But if you choose to use extension or interfaces, these are the semantics that we apply. We are naturally following standard Java language semantics here, translating them to the Spring configuration class model. All right. Just further things you can do with configuration classes. If you need to, you can order them. You can add an order value. Order values in Spring can be omnipresent. In many places in Spring, you can add this add order annotation, and you can assign an order value to methods or to classes. And you can just expect the framework to process the order whenever it possibly can. If you do it for configuration classes, the framework makes sure that the beans in the lower ordered configuration class are going to be initialized first. So we get my bookadmin config first, my application config second. They don't have any kind of other relationship. So if there's no other relationship between those components, we at least order them according to the order value. That can be important if your startup initialization order really requires this class to be initialized first, and then the other one second. It can also be important in a scenario like this one here, where you're using bean overriding by name. It's really my application config one above is meant to override the other one. Overriding by name is a last one wins feature. You really need to make sure that the right one is going to come last. So that's where the order is really important. Keep in mind that ordering is primarily a component scanning problem. So maybe let's quickly talk about component scanning. In a typical modern day Spring application, you're going to use some level of component scanning. You're going to send the framework into some package in your class path and trying to find classes for you based on the type level annotations. Unfortunately, component scanning does not have a well-defined order. So component scanning is primarily a fine choice if the order of registration is not important. But in particular with configuration classes, the order can be important. That's why we allow you to express an order value. If you choose to bootstrap a Spring application context without component scanning, the problem largely disappears, because if you're using annotation config application context, for example, you can say register this configuration class, this other configuration class, this third one. You can be very explicit. You pass the classes, the component classes, into a register call or into the constructor of annotation config application context. There's no component scanning then, and if there are no order values, we're going to preserve the registration order. The order in which you pass the classes into the register call is the default order of the classes for startup purposes then. You can still use that order if you choose to do so, but you can also rely on the registration order as another option. All right, switching a little bit away from configuration classes to the injection point. We've already seen one. Remember in the first example, there was this constructor that took the account repository. We have a variant of this here. My bookadmin service now says, here's my constructor. I want to have a my repository of account. So it says, I know that my repository has a generic type variable, uses generics, and I don't want any my repository. I want one that's typed for account, where the type variable is substituted with account. In the Spring world, we're trying to follow what the class is asking for here. So if it says my repository of account, we're going to take that information. We're going to look at the bean declarations that we have, the bean definitions that we have, and their method declarations in this particular case. So let's assume that the add-bean methods above, they live in some other place. They live in some configuration class. Can be in a very different part of your code base. But if there are, say, two add-bean methods, one of them returning a my repository of account, the other one returning a my repository of product, then we have pretty explicit type declarations. This one below says my repository of account. We only have one add-bean method that also says my repository of account. The other says my repository of product. Different thing, right? The framework is now going to do the obvious thing for you, at least in the Spring Framework 4 generation. It's going to match this injection point here to the my repository of account method above. It's going to select the right one for you. In Spring Framework 3, you would have got, without further metadata, you would have got a non-unique resolution exception, right? It would say like, there's more than one my repository. I don't know which one you mean. Well, it didn't look at the generic type information. Just as of Spring Framework 4, that's what it does by default. There's no need for additional metadata now. No qualifiers. There's no need to say add qualifier account down here or add qualifier account up there. No need to refer to the bean name either. Just use the types. And that's a principle in Spring's component model these days. If the generic, or generally, the type information, the type declaration in your code, in your application code, if that type information is sufficiently expressive, there's no need to add additional metadata. The framework reacts to the richness of the type information that you provided with. Very Java language centric. If the method signatures, the constructor signatures are basically rich enough in what they express, the framework can do the job for you without further information. It's actually, it's worth mentioning, this is actually not a key, so it doesn't have to be identical. It's not like my repository of account down here and my repository of account up there. It's actually about assignability. The bean that the method up there produces needs to be assignable to the injection point down here. So our my account repository method up there could actually return a my repository impl of account. As long as it's assignable to my repository of account, the framework is going to select and inject it. It's about assignability, just like in the standard Java language. If the Java compiler has like a variable typed to my repository of account and an assignment on the right-hand side, it's trying to find out whether it's assignable if you have a corresponding instruction in your source code. The Spring framework is going to do exactly the same thing. It's going to follow the same algorithm in a scenario like this one. Ordering again. What about an injection point that says a list of my repository of account? You can design a constructor that looks just like that, right? List of my repository of account, in terms of runtime behavior, sends the framework on a search for my repository beans in the context, typed to my repository of account, assignable to my repository of account, and it's going to collect all of those into a list. And that list is then going to be injected into your constructor. So if we have two my repositories of account above, we're going to build a list with instances from both beans. Now, in which order are they going to come? Well, there's a registration order, but otherwise there's also the add order value. If you choose to assign an order value, we're going to pre-order them for you and going to pass them into this constructor. Keep in mind that method declarations on the class are not necessarily coming with a well-defined order. The Java compiler basically has its rules, but between different compilers, the class file may have the methods in a different order. So if you do rely on ordering, it's a good idea to be explicit in this particular case as well. All right, further variants of injection points. Now it's not a list anymore, it's a my repository of account again. But now it says add lazy. This particular reference is supposed to be a lazy reference to a my repository of account. What does this really mean? It's a semantic hint. When designing this class of yours, you're basically saying, my bookadmin service needs a reference to a my repository of account, but it doesn't really need it right now. It wants it in the constructor, but it's not going to call a method on it right now. It's probably just going to store it in a field. So semantically, you don't need a fully initialized my repository of account at that point of the constructor call. It just needs to be fully initialized once you're trying to call a method on it. That's exactly what add lazy means. Add lazy means it's a lazy initializing proxy. You get a proxy for the real target bean. And this real target bean is only going to be fully initialized once you start calling methods on it. It may be initialized because of other reasons, right, in the system, because somebody else initialized it before. But from the design perspective of your my bookadmin service here, you're not requesting immediate initialization. This may be a very important semantic to add. It's a way to resolve initialization order problems. It's a way to resolve circular references. bean A needing bean B needing bean A, if both of them insist on a pre-initialized version of the other, it's an unresolvable conflict in the end, right? We're going to try to resolve it for you, but it's not a well-defined runtime arrangement. By one of them at least one of them saying at lazy the other, it's resolvable. One of them wants the pre-initialized version of the other, the framework is going to find out for you what the proper runtime representation is. Lazy markers can be pretty important. Lazy markers can also be found at the @bean level, but they have slightly different semantics. It's about startup initialization of single beans primarily. @lazy says, do not initialize this bean until it's used. Whereas the default framework behavior is, oh, there's a singleton bean. We can do early initialization, so let's try, right? @lazy explicitly opts out of early singleton instantiation. All right. A quick look at standard Java X dot something imports. What we've been seeing up until this part of the presentation is Spring annotations. We haven't seen the imports, but fundamentally you import Spring annotations. @autowired, @transactional, all of those annotations come from org.spring framework packages. You may also choose to use some standard annotations coming from the Java X packages instead. And this is a variant of our example that just uses imports from javax.annotation and javax inject. @managedBean is a simple stereotype from javax.annotation, the JSR 250 annotations. @inject comes from JSR 330. @predestroy comes from 250 again. Spring automatically understands those. So if you choose to use those annotations in your classes, in your code base, the framework automatically knows what you mean. No need to activate anything, no need to configure anything. We automatically know what those annotations mean. @inject can be used as a replacement for @autowired, for example, pretty much directly. But there's one thing @inject cannot do. You cannot say a target reference is optional using @inject because it's just not there in the annotation. Whereas @autowired can say required equals false. So this example provides actually a solution for this subtle problem. If you want to have a lazy option, in this particular case, for example, a lazy reference to a target bean, and you don't want to use the @lazy annotation, you're already in a kind of problem of expressiveness, right? Spring's annotations have a way to solve the problem. @autowired can express optionality, can express lazy references. @inject, by default, cannot. But if you want to use the JSR 330 provider mechanism in combination, that's a nice solution for the lazy access problem. Declare your argument as a provider of my repository of account. Then you get a provider handle with a get method. And when you actually need your target bean, call get on that provider, which gives you a reference to the target bean, and perform your method call. It's not a proxying mechanism. It's a lazy get access mechanism, but it's a solution to the same problem. So we have quite rich ways of expressing those characteristics. This is one way of doing it completely without Spring imports. And even the already touched upon optionality can be expressed this way. @inject, in combination with an argument that uses the Java 8 Java util optional type, can easily express optionality. So my book admin service here says, I want an optional reference to a my repository of account. That's exactly what you get. If the target bean can be resolved, you get an optional Java util optional handle with the reference inside. You can react to it based on the Java util optional API. If it cannot be resolved, you get optional empty. Again, no Spring imports, no Spring metadata needed. This can all be expressed with Java language semantics, the Java 8 optional type, and the Java x.inject inject annotation. All right. While we're talking about Java 8 Java util optional, something different from Java 8 to be found here. It's an example for using the java.time types. Java 8, of course, comes with a new java.time package. It's kind of a variant of JODA-time with local date time, local time, zoned date time, instant, and so forth. So if you're using this in a Spring-managed binding scenario, the framework automatically understands those types and the semantics of those types. Spring is not only about dependency injection, it also has a rich binding and formatting framework, for example. And let's assume that customer is some kind of domain object or form object that is going to expect some text representations to be bound onto its fields, say from a web form or from some kind of text representation in a binding scenario. In traditional arrangements, you need extra metadata here. Like at datetime format says, this is a specific kind of date, please parse it like that. Or down here we have even a pattern associated. So an incoming text representation is supposed to be parsed according to this pattern. And if we're rendering it out, again, we're going to use the same pattern. Standard functionality in Spring's formatting framework. The nice little new twist comes in through the local date time, those specific types. If you are saying local date and you want it to be parsed like a standard ISO date, there's no need to add extra metadata, no need to add an annotation. That's why the datetime format annotation above is commented out. You can just omit it, skip it. Because local date itself says, I am a date representation, no time information inside within that day. So we know how to parse it. Since the type is expressive enough here, there's no need to add extra metadata. It's a continuation of that theme in Spring's component model design. This, of course, also works with Joda time. So if you're using the Joda time types here on Java 6, 7, or even 8, we understand the same semantics. We know whether it's a local date, a local time, a local datetime, a zone datetime, and we have rich, meaningful default representations to apply to all of those. Don't use Java util date or Java util calendar. There's no semantic information in there, whether it's a date or date plus time within the day. Those types here are way more expressive. This is important information to provide to binding frameworks, to persistence frameworks. Many frameworks can react to the semantics of those new standard types now. And Spring does it for you out of the box here. A quick note in Spring Framework 4.2, you can even do this to the brand new GSR 354 money and currency types. Money and currency went final in April, so half a year ago. It's pretty new still, and comes with a couple of new types. Monetary amount, for example, currency unit, and it comes with a rendering framework behind them, parsing framework behind them. As of Spring 4.2, we automatically understand those types. If you're using them, we know what the monetary amount is. We know what its default representation is. We know how to tweak it. So if you assign a number formatting pattern, we're going to use it and produce a monetary amount for you. Monetary amount is basically a currency symbol and a number in a proper form, not in the form of an int or where the currency information is lost. In a combined, rich object with currency and the value inside, right? So this comes out of the box. Just import those types, use them in your classes. As of Spring Framework 4.2, the framework does the right thing for you by default without extra configuration. And another little example for what we're doing with recent Java features. This is Java 8 again. It's actually two Spring features again. It's add async and add scheduled. Add async is basically a way to take a method and have it automatically wrapped into a callable and passed onto some thread pool for asynchronous execution. A feature that has been in the Spring component model for about 6 years now, since Spring 3. Works the same way, of course, even in modern day Spring, but there's now a couple of interesting things you can do with it. The example in the middle is not just returning a future. The future is kind of the Java util concurrent future, is a handle that the caller can use to track the execution of the asynchronous method. But as of Java 8, we have completable future as a really rich composable future variant. It's actually not an interface, it's a type with a lot of extra methods to compose the outcome with other futures. If you declare your method to return a completable future, then Spring understands it at runtime. It knows that you are asking for a completable future, so we're going to adapt it to a real completable future for the configured thread pool for you. So we know what the signature says, we react accordingly. And completable future even has a nice little factory method, a static method, that allows you to return the pre-computed result within the method. Because the caller gets a real completable future, talking to a thread pool. Our implementation here needs to return its computed result in some form. So it can use a wrapper like the async result thing above, or it can use the new completable future dot completed future convenience methods. And another Java 8 variant can be seen below in the same domain. AddScheduled is about asynchronous triggering of a certain method whenever a trigger fires, whenever a cron trigger fires in this case. Every time the cron trigger says like fire now, this method gets a callback at runtime. But we don't just have one cron trigger here, we have two. Two AddScheduled annotations with two different triggers. The nice thing as of Java 8 is you can actually do it like this. You can redeclare AddScheduled a second time. Looks very natural, but it's only really possible as of Java 8. Prior to Java 8, right, in previous versions of Java, you could not do this. You had to use a containing annotation like AddSchedules with nested AddSchedule annotations because you could not repeat the same annotation type more than once on the same method or the same field, whatever it is, right? As of Java 8, annotations can be declared as repeatable. That's what we're doing out of the box for selected Spring annotations like AddScheduled. So you can just do it very naturally like this here. No need for a container annotation. A Java 8 language feature, repeatable annotations, applied to a Spring component model element. Just working out of the box. Okay, so to wrap up this little discussion, I'm just going to show you a few brief examples about the endpoint style. We're not going to discuss those in detail. Take it from a design perspective. What's the impression of those classes with their annotations inside? This is something you're probably familiar with, Spring MVC endpoints. A Spring MVC controller with request mapping annotations, taking a method, turning it into a handler method, binding it to a specific HTTP path. So whenever a corresponding web request comes in, the dispatcher is going to select one of those methods and it's going to invoke it for you. Type level annotations, it says add REST controller here. Stereotyping again, right? The Java class says, I have a specific role. I'm a REST endpoint. I'm a REST controller in Spring's terminology. And each of my methods here has a specific request mapping. The add request mapping annotation binds certain handler methods to specific incoming requests. Each of those methods can have a variable or a flexible method signature. So it can choose to declare certain methods, certain method parameters. The framework is going to resolve them for you. So our findBook method here says, I need access to a path variable from the incoming request named ID, and I need it pre-converted to a long. So the framework is going to extract the ID part from the path mapping above. It's going to extract it from the incoming request path. It's going to convert it to a long, and it's going to call your method with that computed value. So that's Spring MVC controllers from a design perspective. Now, what if you did something different? Also a web application, but it's using WebSockets, and it's using the STOMP protocol, the STOMP messaging protocol, on top of that WebSocket channel. What would the endpoint look like in Spring? This is a sketch for what it looks like, what it could look like. Standard Java class, stereotype annotation, controller above, mapping annotations on each method. But here it's not request mappings because you're not mapping to HTTP web requests, to typical standard web requests. You are mapping to messages from the STOMP protocol, right? So you have message mappings for regular STOMP messages, and you have a subscribe mapping for STOMP subscribe messages. So we take the elements of the actual protocol, STOMP in this case, allow you to bind to them very specifically using the same style. It's not the same annotations. It's fundamentally a different domain, but it's stylistically similar to request mappings in a Spring MVC controller. And the parameters are, again, flexible. In this case, you are asking for the payload. The message mapping extracts the payload from the message pre-converted to a trade domain object according to the configuration of your STOMP architecture. And the principle is the Java security principle that comes with it. We understand what you mean if you declare that as an argument. We're going to resolve it for you. So, well, that's the main two domains already, Spring MVC request mappings and message mappings. There are a couple of variants of message mappings. So in case you're into GMS, this is what it would look like with GMS. Would also live within a class, might be marked as a controller, some stereotype on top, and the method says, I'm a listener for this particular GMS destination. GMS is about listeners. It's a slightly different concept. No WebSocket channel underneath. We register GMS message listeners for you. The example above is the simplest possible form. You see, at GMS listener, this destination. And you extract the payload as an order argument here. If it's as simple as that in your architecture, the first example is all you need. If you need to be more specific, you can also go much more specific, right? The second example says, I'm a GMS listener for this particular container configuration, with this particular message selector, with this concurrency level. And it's even extracting a GMS header from the incoming message. Your choice, right? You can be as specific as you need to be. Spring's annotation endpoint model allows you to be very, very concise if you can. If you need to be more expressive, it allows you to be more expressive, depending on the domain that you're mapping to. We do differentiate between GMS, STOMP, and regular web requests, right? But we do it in the same style. And even Spring application events, a brand new Photo 2 feature, just look at the design, right? Endpoint methods annotated with @EventListener, taking payloads as a method parameter, the same design concept for endpoint methods, endpoint handler methods, even for internal application events that you can consume within your application. We're really trying to be consistent in our design arrangement for many different domains here. All right, well, so much really for the endpoint design. I've got a bonus slide for you, if you're up for it. I have been mentioning caching before. What does caching look like in terms of the annotation style? Just look at this, right? It's about methods. It's a little bit like @transactional, right? Look at the find by ID method. It's not transactional, it doesn't say @transactional, but it says I'm cacheable. This method, the find by ID method, is cacheable, reads nicely. It's again about readability of the source code. And at runtime, if you activate caching, the framework knows what to do. It's going to intercept the call, compute the cache key from the parameter signature, and it's going to do a lookup into the cache. Is there a corresponding object? If yes, take it. Don't call the method. If not, call the method, compute the result, put it into the cache and return. So that's the basic principle and the basic design behind caching. And just in case you're wondering, and if you know that there is a set of standard annotations from GSR 107 in the javax.cache package, of course, Spring understands those annotations. If you're using them, if you're using @cache result in the middle here instead, we know what to do with it. We know how to intercept it. The terminology may be different. The annotation design may be slightly different. But it's your choice whether you want to use the Spring set of annotations or the standard set of annotations, as we've seen before when we were talking about auto-wired and @inject. All right, that's really the end of the tour for you. Thanks for staying on board. Right? It's been an extensive tour. We've been touching on many different subjects, many subtleties in Spring's component model. This is not the end of the road. It's the state of the art as of Spring Framework 4.2. Went available in late July, generally available in late July. We're currently preparing work towards Spring Framework 4.3 already. So you're getting a new feature release with some revisions, some new features in the course of this programming model in May next year already. Spring Framework really has a tight release schedule. Roughly every 10 months, there's a new feature release. Many of the things that I've been showing are actually recent additions. Event Listener, JMS Listener, some of those things have been introduced in 4.1 and 4.2. We bring brand new programming model, component model features to you every 10 months without raising the system requirements. You can just upgrade in your existing target environment and benefit from these latest component model features as I've been showing here. And the next iteration is going to come in May 2016. Thanks for your attention. Thank you. One more note. We have a Spring BOF, a Birds of a Feather session, basically questions and answers, Tonight at 5:15, 17:15, in some room downstairs, Stefan and I are going to be there to take any questions you may have, be them about Spring Framework or Spring Boot or anything else in the Spring portfolio. So if you want to have an extended conversation with us, we are both core Spring Framework members, and Stefan also a key member of the Spring Boot team. We're happy to discuss anything you have on your mind in that BOF session later today. Thank you.